All right, this video reviews the second part of geometry that you learned in grade 7, and that is the special types of angles that are formed when a line cuts through parallel lines. Remember that the line that cuts through the parallel lines is called the transversal. So this blue line here, which I've just highlighted in yellow, that's called the transversal, and that line cutting through two parallel lines will create angles. It's also important when you're doing these questions that you know lines are parallel if you see these arrows. If you do not see these arrows, then do not assume the lines are parallel, and you're going to have to use other methods of finding missing angles, like opposite angles or supplementary angles. So some of the special angles that are created, the first one is called alternate angles. Alternate angles are formed by using the Z pattern, and they're on opposite sides of the transversal. So again, the parallel lines would be indicated with arrows. Oops, that one didn't work very well. And your transversal would cut through the parallel line, and then you're looking for the letter Z. And that will create what's called alternate angles. One could be there and one could be there, and those angles are going to be equal. Notice that they are on opposite sides of the transversal. Now, it doesn't actually have to be a Z. You could also have like a backwards looking Z. Sometimes it also kind of looks more like a lightning bolt. What you're trying to do is you're trying to use the two parallel lines, form the top and bottom of your Z, and then the transversal forms like that diagonal part. So the next type of special angle that's created is called a corresponding angle. And corresponding angles are on the same side of the transversal. So again, if your parallel lines are denoted by the arrows, this one you're looking for the letter F. Again, what you're looking for is for the stem of the F to be the transversal, and then the two little pieces that make the F are going to be the parallel lines. So for example, here is my F pattern, and what that does is it allows the two angles, I call them under the kind of the armpits of the F, this part here, those two angles are equal. Notice that they are on the same side of the transversal. Now again, your F doesn't have to look exactly like an F. It could be a backwards F, like that. It could actually also be like an upside down F. For example, this is also an F. So just keep that in mind when you're finding the angles. And then the last type of angle that is formed when a transversal cuts through parallel lines is called co-interior angles. Now this one is the C pattern, and it's slightly different because these angles are not going to be equal to one another. They're going to add up to 180, just like supplementary angles do. So here again, you're looking for a C pattern, and right there is the C. Again, kind of the stem part of the C is the transversal, and then the top and bottom of the C are the parallel lines. And so what happens for this one is the two angles that are kind of underneath the C, so the dot and the X, they again are not equal, but the dot and the X together will equal 180 degrees. Again, sometimes it's not going to be a C. You might have like this backwards looking thing. It might look more like a U, depending on the way that the parallel lines go. So let's look at some examples with that. So in the top example, you have a parallelogram, and there are a series of parallel lines, and so you need to find the missing angles. So one of the first things that I would do is I would say, okay, this shape right here is a triangle. So I know that the angles in a triangle add up to 180 degrees. So I'm going to do 35 plus 75. I'm going to get 110. And then I'm going to subtract from 180, and I'm going to get 70 degrees. And so then I know that y is 70 degrees. Interestingly also is that in a parallelogram, the angle here and the angle here are going to be equal to one another. So if y is 70, so is z. Now, how do I get x? Well, one thing I can do, again, is look for these patterns, and I'm going to see that there's a z pattern right there. And what that tells me is that this angle and this angle have to be equal, so x has to be 35 degrees. So the bottom example, we're actually starting to combine some of the algebra work we did with some of the knowledge that we have of geometry. And so again, I know that I've got parallel lines because I see these arrows. So I have to think about what's the relationship between this angle and this angle. And what I hopefully will see is I'll see that there is an F pattern. And what that tells me is that this angle here and this angle here must be equal. And so what I'm going to do then is create an algebraic equation based on my knowledge of geometry. And now I'm going to solve that equation based on my knowledge of algebra. So I'm going to have my x's together. I'm going to collect like terms. I'm going to put my constants together. I'm going to simplify each side. I'm going to solve for x. Now, once I solve for x, that does not mean that the missing angle was 45 degrees. What I then have to do is substitute. I can substitute into this one. I can substitute into this one. It actually doesn't matter because they're equal. It's going to be easier for me to substitute into the x plus 15. So what I can do is I can say, okay, well, x plus 15 is that angle. And that's x is now 45. So 45 plus 15 is 60 degrees. And now that I know that x was 45, sorry, I didn't fill that in here, and that that angle is now 60 degrees, I can find some of the other angles. For example, I know that A and that angle are supplementary. So I know then that A must be 180 minus 60, which is 120 degrees. I also know that this angle and C are co-interior. Do you see there's a C pattern there? So again, I can use 180 minus 60. I could have also seen that there's an F pattern with A and C. So regardless of how I get the answer, and there's always more than one way, I'm going to get the answer of 120 degrees. Finally, I know that C and B are opposite, so B must be 120 degrees. So that's just a quick refresher on how you can solve using parallel lines and angles.